Okay, so how you just calculate the chi-square test? So I will tell you the calculation of the chi-square, or you can also say it as a cross tabulation or the chi-square. They are the same thing. So in the two methods, you can calculate the chi-square. Or if you want to just only the descriptive statistics, then you can go to the descriptive statistics and the cross tab. But if you want to know the it means tables. Okay, in the descriptive statistics, just go to the descriptive statistic and go to the cross tabulations, or you can see the chi-square test. So when you click on the cross tabulation, so there will be options in the row and columns. So you can just put the values here, or you can put the variables. That may be the demographic variables or any Likert scale variables or the continuous variables. So for example, I want
Good
to just
afternoon, sir. Sorry, sir,
yes,
your screen is not visible, sir.
screen is not visible.
No, sir, it's
Sir,
visible.
it's visible, sir.
Okay.
Visible, sir.
No, sir, it's not visible.
You can just
Visible, sir. Screen is
you can
visible.
reload, you can just refresh or reload, or you can just open the app again, or the you can just refresh the browser.
Okay, sir.
So if you want to check the association between the two variables, or you want to check the homogeneity, then you have to just, for example, I want to just check the homogeneity between the age and marital status. You can just put the age and the marital status like that, or you can also put the more than the one variable here. Exact, we don't need to do anything in the exact. Statistics, so you can apply the chi-square test in that, or you want to check the association between the both the variable, you can also take the correlations if you want to check the correlations. Then if you want to just check the homogeneity, we know whether there is a nominal or ordinal. So we have the nominal data, okay, like the contingency coefficient, phi, and the Kramer's V model or lambda. You can apply that for the homogeneity. So in the case of the data original, so you can apply these tests. So in that case, we have the like that, the age or the marital status. So you can see that in the column marital status is the nominal data. In nominal case, you can apply the lambda, or you can also check through the another method, the homogeneity between the both the variables. Then cells is the observed. If you want to also show the percentage row wise and column wise, you can tick. If you want to just reflect the percentage, what is the percentage of total row and the total column. Format, you can put the ascending or descending order. Style, yet it's for the bootstrapping. Now it's for bootstrapping. Now in that case, when you will click on the okay, or if you want to display the cluster bar chart, you can also tick here the cluster bar charts. Okay, so in that case, you can see it will generate the three main table. One is the cross tabulation between age and marital status. So in that case, it categorizes all the data in the row and columns. In the row heading, you can see the row heading is the row heading the married and unmarried, column heading the less than, column heading the married and unmarried, that is the marital status or diverse. There were three categories, and in the you can see the in the row headings there is a age. So the people who are the less than 20 years, the 4 are married and the 15 are unmarried, and divorce is 0. So same like the all the categorical all other categories are divided as per according to the column and the row which we have put in the cells. So in the row we have put the age groups, and in column we have put the marital status. So this is the chi-square test. So this is the we have need to explain that values. So in that case we have this count the default count is the less than 5, and you can also change the default count. So but in that case we already have the default count. We didn't change the default count, so that is the 5. So in that case you can say it will show the Pearson chi-square, the likelihood ratio, and the linear by linear association. So all these things you can say is the significant, means the values means association. There is a strong relationship or association between the variables. That's why there is a significant relationship or significant association between the age and the gender. A likelihood ratio, which both are also have the association of strongly likelihood ratio between the age and the marital status. It's also having the less also the values is less than 0.05, means 5% level of significance. So our hypothesis accepted, means a normal hypothesis accepted, but no, not null hypothesis. If in the case of the null hypothesis it is rejected, but in the nowadays we are taking only the directional hypothesis, not null hypothesis, not alternate hypothesis. In the thesis or in the any synopsis we only just take the directional hypothesis. That what type of hypothesis? Like that there is a significant association between the age and the gender. There is significant association between the age group and the marital status. There is association between the age group and the marital status, like that. So that is directional hypothesis. Instead of there is no significant instead of negative hypothesis, we always just takes the significant. We always take the normal hypothesis, or you can say the directional hypothesis. So in that case, if you have directional hypothesis, your result will be like that. 8 cells is the, you can see the 8 cell total, 8 cells are there. This is the expected count is the less than 5. So the minimum expected count is 0.07. So is the less than the 0.07, or you can see the 53.33%. So total 8 cells are just explaining and having the coordination and correlation association 53.3%. So in that case also you can say if we take about that expected count, so you can see the bottom of the table, the minimum expected count is 0.07. So this is less than the 0.07. In that case, if you want to just check the likelihood ratio, so that also showing the less than 0.07. So we can also see there is a significant association or likelihood between the age group and the marital status. So this showing the significant results. And next is directional measures. In the directional measures, we have checked the lambda. So lambda is showing the approximate significance between the both the age group and the marital status. So in that case, it's showing the both the things. The age, you can see here. So the age dependent and marital status was also the dependent. The age dependent and marital status. So that is Goldman and Kruskal values test and the lambda test. In the lambda test, you can see the symmetry, both the values having the 0.93 symmetry. So there is a less symmetry between the both, and as asymptotic standard error is the 0.029, and the approximate the association is the 2.896. That's showing the association, and the value approximate significance is also showing the significance between the we talk about the symmetry. So in the case of the symmetry, it's showing the very less symmetry because the value is 0.093. That is 0.019. It shows also very less symmetry. The marital status, it also having 0.30. It's showing the strong symmetry. between marital status. So its value is 0.010. So these are showing the a nominal by nominal. We are just checking the nominal by nominal because the both the variables are nominal. We take the nominal. So in the case of the nominal case, it's showing if you are taking the both the variable as a nominal, so the symmetry value will be like that. We are not assuming any null hypothesis here, and using the asymptotic standard error, assuming the null hypothesis and based on the chi-square approximation. So these are test, and the age and dependent marital status is also showing like that. In that case, Goldman and Goldman and Kruskal values test is also showing that there's a low asymmetry between the age and the marital status. So it's result saying that there is less symmetrical relationship between the nominal to nominal if you just select the nominal to nominal. But again, you can just check with the ordinal, because the age also we can also categorize the age in the ordinal sense. So you can just also check with the ordinal key whether the ordinal symmetric is high or the nominal symmetric high. Main table is to you have to explain is like that chi-square test. That is the main things you have to be explained. So it's showing the significant result. It means there is a significant relationship between the age and the chi-square age and the marital status. So Pearson chi-square, it shows the Pearson chi-square. We just calculate the Pearson chi-square in the case when there is a nominal ordinal data. But in the case of continuous data or continuous data, so we have to apply the Pearson. Either we have to apply the Carl Pearson coefficient of correlation instead of the chi-square Pearson. So in that case, whether you have the nominal data or the ordinal data, you have to go to the Pearson chi-square. But in the case you have the continuous data or the Likert scales, you have to apply the coefficient of correlation. Coefficient of correlation, Carl Pearson coefficient of, or you can say go to the linear correlation or the multiple correlations. So in that case, if we have the continuous series or the continuous data, you have to apply the Carl Pearson coefficient of correlation. But in that case, if you are nominal or ordinal data, you apply the chi-square or Pearson chi-square. In the case of Likert scale, you have to apply the correlation. 1 minute. Correlation, bivariate correlation. So that is the bivariate correlation, means you have to two variables or linear correlation. So in that case, all these scales I have on the Likert scale. All these are on the Likert scale. So in that case, if you want to just check the correlation between the trust and attitude, so all these are on the 5-point Likert scale. So if the data is the continuous series, then you can apply the Carl Pearson coefficient of correlation. Just put here. Then we have to take here the Pearson. 2 tests or 1 test. We have to apply the 2 test here. The offset is that mean and if you want to also show the mean and standard deviation, you can click here. Then you can just do it. Okay. Then this will be generated here. You can see in this table. So it shows a 0.783 correlation between attitude and the trust. So it's showing the strong correlation between the trust and attitude. And in between the attitude and the trust is also showing the same like that, 0.783. So almost more than 70% showing the strong correlation. So the values, the degree of correlation between the both the variables are the a strong correlations. So you also go through the various degrees of correlation, like the zero is the zero. If the R value or the correlation value is 0, means there is no correlation between the variables. If the values lie between 0 to 0.25, low degree of correlation, positive or negative, that may be positive or negative, low degree of negative. If the values fall between the 0.25 to 0.50, it shows a moderate degree of correlation, positive or negative. If the value is negative, that will be moderate degree of negative correlation. If it is positive, moderate degree of negative correlation. And if the values fall between the 0.50 to 0.75, it shows a high degree of correlation, high degree of positive correlation or high degree of negative correlation if it is the values that comes in the negative. And if the values between the 0.75 to the, you can say the 0.98 or 95, it's a very high degree of positive correlation or very high degree of negative correlation. If the values comes 1, R is equal to 1. If the values will be 1, that will be perfect positive correlation. If -1, perfect negative correlation. Got it? क्लियर? जब हमारे पास ऑर्डिनल या नॉमिनल डाटा होगा तो हम पियर्सन का स्केयर पे जाएंगे। जब हमारे पास अगर कंटिन्यूस डाटा है, हमारे पास अगर लिकर स्केल पे कोई भी डाटा है, तो हम करेंगे कार्ल पियर्सन कोएफिशिएंट ऑफ कोरिलेशन, लीनियर कोरिलेशन। ठीक है, तो यहाँ पे वैल्यू पॉजिटिव आ रही है तो हम कह सकते हैं मॉडरेट, एक हाई डिग्री ऑफ पॉजिटिव कोरिलेशन है एटीट्यूड और ट्रस्ट के बीच में। क्लियर टू ऑल? ये क्लियर हो गया? आवाज आ रही है मेरी सभी को?
Yes, sir, you're clear.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
ठीक है, अब ये का स्केयर है और कार्ल पियर्सन कोएफिशिएंट ऑफ कोरिलेशन, ये निकाल लोगे, कैलकुलेट कर लोगे।
Yes, sir.
अब हाइपोथेटिकल डाटा लेना कुछ, उसको कैलकुलेट करके दिखाना, मेरे को रिजल्ट बताना क्या क्या अगली नेक्स्ट क्लास में कल। कोई भी हाइपोथेटिकल डाटा ले लेना, उसका स्केयर की वैल्यूज मेरे को बताना और आपको कोरिलेशन की वैल्यू। तो दोनों मेथड अप्लाई करके
Okay,
देखना।
sir.
नॉमिनल ऑर्डिनल है तो आप इसमें जाओगे, का स्केयर पे जाओगे, तो मैं दोबारा बता देता हूँ, एनालाइज में जाके आपको इसमें जाना, आपको डिस्क्रिप्टिव स्टैटिस्टिक्स में जाके क्रॉस टैबुलेशन पे जाना है। ठीक है, क्रॉस टैबुलेशन पे जाओगे तो वहाँ पे का स्क्वायर आपको टिक करना है, वहाँ पे आपको पियर्सन का स्क्वायर की वैल्यूज भी आ जाएगी साथ के साथ, और उसको आप एक्सप्लेन कर सकते हो। और आपके पास अगर कंटिन्यूस सीरीज है, 2 वेरिएबल्स हैं आपके कंटिन्यूस सीरीज पे, तो आपको इस पे कोरिलेशन पे जाना और आपको बाइवेरिएट पे जाना है। ठीक है, क्लियर? If you have any doubt, any queries, you can ask. Okay, thank Okay, thank you so much. Now you can leave.
Sir, thank you so much. Thanks a lot. Have a nice
Okay, thank you, sir. Thank you so